Percent change math review. Number 1, make sure that you have memorized the percent change formula, as you will need it for the AP test. Number 1, you're going to do the percent change from 100 kilometers to 125 kilometers. So it's our ending amount minus our starting amount divided by our starting amount. So we're going to do 25 divided by 100, and you can see that this 25 of 100 is really a 25% increase. So that one is pretty easy to do without any kind of a long division problem. Number 2, from 25 hours to 20 hours. So this was a decrease. So it's 20 minus 25 over our starting number of 25. And we're going to end up with a negative 5 over 25. And so we're going to do a long division problem. Here's our decimal, bring it up, add a 0 here. 25 goes into 50 twice perfectly, but this is negative, so don't forget your negatives. Here's a negative 5 there and a negative 0.2 here. And then we multiply this by 100 to get our percent change. So we have a negative 20%, and so we can say that it's a 20% decrease. Number 3, going from 70 grams to 75 grams. So ending number minus starting number over starting number. And we end up with 5 over 70, and the grams just cancel out. Whenever you do percent change, all the units are pretty much going to cancel out. So now we have 70 going into 5. Here's our decimal, bring it up, add another one here. Now 70 does not go into 50, so now I'm going to put one here and here. Notice I have one more at the bottom than at the top of zeros. So now 70 goes into 500, goes in 7 times. 7 times 70 is 490. And we're left with 10 as a remainder. Add a 0, bring it down. 70 goes into 100 once. Now, if you'll notice your problem, it says to round to the nearest whole percentage. And it looks like we can actually stop here, because when we take this number and we multiply it by 100, we get 7.1%. And it's round to the nearest percent. So the reason why I stopped the math again right here, I just stopped it there, was because I knew that I was going to round to the nearest whole percent, and as long as I have this number 1, I know which way to round. I know I'm going to round down to 7 and not up to 8. So that's where I can stop the problem. Number 4. Going from 3 inches to 10 inches, and here round again to the nearest percent. So we're going to have our ending number is 10, and our starting number is 3, divided by 3. We end up with 7 over 3. So now we're going to do kind of a big, annoying long division problem. And so I'm going to go ahead and solve it. Here's my decimal here. Make sure, don't forget your decimal. And I'm going to drop this 0 down. So 3 times 3 is 9. It's not a very hard problem. It's just a little bit annoying. It looks like I'm going to have this continuing thing here. So I'm going to stop here because I know that when I multiply it by 100, it will move the decimal point over once twice. And so my answer will be 2.33 per, I'm sorry, that is wrong. So Let me erase that. All right. And it's going to be 233%. So it says to round to the nearest whole percent, so I can round to 233%. So again, I just needed to go as far as getting to the tenths place to know whether I needed to round up or whether I needed to round down, and I didn't have to go any further than that with my long division problem. Number 5, going from 45 meters to 90 meters. Oh, and by the way, number 4 was also an increase, 233% increase. All right, so our ending number is 90. Our starting number is 45 divided by our starting number. And so 45 divided by 45 gives you 1. We're going to multiply that by 100, and that gives you 100% increase. So that's a nice, easy one. Anytime something doubles, it increases by 100%. That does not work by having somebody decreases it by 50%. Number 6, from 12 liters to 6 liters. So now it's a decrease because it's going to be 6 minus 12 over 12, and we're going to get a negative 6 over 12. And we know 6 over 12 is basically a half, so a negative half. And so then we know that's a negative 50% because a half is 50%. And so we're going to write it as a 50% decrease. Now we're going to do some word problems. Number 8. Black-footed ferrets. Okay, so this was actual numbers that I looked up. 1987, the population of black-footed ferrets in the world was 18, only 18, but through captive breeding, that number rose to 120 just in 2 years. What percent change is this? And you're going to round to the nearest whole percentage. So we're going to take our ending number minus our starting number divided by our starting number. And we're going to get 102 divided by 18. So here's our long division problem. Here's our decimal, bring it up. All right, so 18 goes into 102 5 times. And 5 times 18, and again, off to the side, do your scratch math. Pause the video, do your scratch math. 5 times 18 is 90. We're going to subtract, and we're going to get 12. We're going to add a 0. We're going to bring it down. And now 18 goes into 120. It goes in 6 times. 6 times 18 is 108. Subtract, and we're going to end up with 12. Have a 0, bring it down. Oh, this is going to be repeating. It's 120 again, so it's going to go in 6 times. And we're going to subtract. We're going to get 12, etc. All right, so we know that we can actually stop because we know it's going to repeat on and on and on. So we know that we're going to multiply this number by 100, which is also just moving the decimal point over, and we know we need to round to the nearest percent. So we're going to continue the problem until we get the number we need to round to. So we know because it ends in a 6 that it's going to round up to 567% increase. Oh, and I made a mistake on this one. This is not number 8, it's actually number 7. Going on to number 8. The number of kilometers of wilderness increased from 4.0 times 10 to the 4th to 6.0 times 10 to the 4th in a decade. What's the percent increase? So we are nice and lucky in that it's both 10 to the 4th. So we don't have to do a change in the exponent to first subtract. So We're going to take 6 times 10 to the 4th minus 4.0 times 10 to the 4th. It would be 6.0 also. And this is divided by 4.0 times 10 to the 4th. So it looks like some wilderness was protected. So when we subtract, because both of these exponents are the same, we're in good shape here. We don't have to change them. So all we do is 6 minus 4, and our answer is 2 times 10 to the 4th. And this is going to be divided by 4 times 10 to the 4th. So when we add or subtract exponents, we want them both the same. But when we multiply or divide the exponents, they actually will subtract for division. When we multiply, they add, but when we subtract, when we divide, they actually subtract. So it would be 4 minus 4, which cancels themselves out. So our answer ends up being 2 over 4, which is a half, which is an increase of 50%. So this problem ended up being really easy, even though it looked terrible to start with. Number 9, a 2,500 hectare piece of wild chaparral was bought by a developer and turned into homes. A hectare is metric for acre. The developer built homes on 1,000 acres and left the rest untouched. What was the percent decline in wild chaparral? So there's a hint on here that you first need to find the decline in wild chaparral, not percent developed. So you need to subtract first. The hint part is me. The AP test will not give you a hint. They have questions like this where they first expect you to subtract and then find the percent change. And you have to catch that. So most of the multiple choice questions on the AP test are really two-part. If you just did it in one step, you probably did it wrong. I'm not saying all the time, but you often did it wrong. Now that's for multiple choice. For FRQs, sometimes it can be just a one-step simple problem. So we have untouched wild as 1,500 left. And so our ending number is 1,500 hectares. Our starting number is 2,500 over 2,500, and that gives us 1,000 divided by 2,500. And so we are going to divide now. This, by the way, is a negative, so it's going to be a decrease in wild chaparral. So when we do a long division problem, we can actually first cross out the same number of zeros at the bottom and at the top. Do not cross out all the zeros on both sides. You have to cross out an equal number in the numerator and the denominator. So this makes it a little bit simpler, less zeros to work with. So I have 25 going into 10. And this is actually a negative 10. Don't forget your negatives. Here's a decimal, bring it up. This does not go in, so I'm going to add a 0. And now it goes in evenly at 4. And so our answer is negative 4. And we multiply that by 100. It's 0.4. And so when we multiply 0.4 times 100, we end up with a negative 40%. And so we say that that is a 40% decrease in wild chaparral. Number 10. A car maker improved the miles per gallon of a car from 22 to 32. What percent change is this? And you can round to the nearest whole percent. 32 minus 22 over 22 gives us 10 divided by 22. So now we're going to do that long division, and we need to do it long enough to make sure that we can round correctly and know which way to round. So here's our decimal, bring it up. It does not, 22 does not go into 10, so I'm going to add a 0. And now I know it goes in 4 times. 4 times 22 is 88. I'm going to subtract, and I'm going to get 12 as my remainder. I'm going to add a 0, bring it down. So now I have 22 going into 120, and it goes in 5 times. 5 times 22 is 110. I'm going to subtract, I get 10. I'm going to add a 0, I'm going to bring it down. 22 goes into 100, goes in 4 times. 4 times 22 is 88. I'm going to subtract, I'm going to get 12, I'm going to add a 0, I'm going to bring it down. And 22 goes into 125 times. So now I have plenty of numbers so that when I multiply it by 100, I'm going to get 45.45. And this basically tells me how to round. I could have even stopped a little bit sooner. So I'm going to round 5%, and it is an increase. 11. Between 1950 and 2000, global meat production increased from 52 billion kilograms to 240 billion kilograms. During this period, the global human population increased from 2.6 billion to 6 billion. Calculate the per capita meat production in 1950 and 2000. This was from an AP test FRQ several years ago. So it sounds awful, but it's really not. So let's just kind of go through. In 1950, let's figure out how much meat per capita means per person. So we have 52 billion kilograms of meat, and this is divided by 2.6 billion people. We'll say persons. So one of the nice things is that since you're not allowed to use a calculator, they cancel, and the math doesn't end up being terribly difficult. Look, I can cross out billions here. And so now my 2.6 going into 52 is pretty easy. I didn't have to worry about all those zeros. Since we have a decimal point over here, we got to get rid of it. On that side. We don't want it over here. That's the bad side for a decimal point. So I'm going to take the decimal here, and I'm going to move it over also. So I moved it over once here. I've got to move it over once here. Fill in with a 0. Bring the decimal point up. So my real problem now is 26 going into 520. And it goes in nice and evenly. 26 times 2 is 52. And so I'm going to fill in this last one with a 0, and it's really 20 kilograms of meat per person. And that's 20 kilograms of meat per person. And the next part is the same sort of thing. So in the year 2000, we went up to 240 billion kilograms of meat. And now we're up to 6 billion. So this was a while ago. So we're up to 7.5 now of people in the world. But at the time it was 6 billion. We canceled those out. And 6 goes into 240 nice and evenly at 40. So this would be 40 kilograms. And so those are our two answers, 20 kilograms of meat per person and 40 kilograms of meat per person. So there were two answers to that question, and that's what it was. Now, on an FRQ, make sure that you write out all of the units. So you have here, that's one of the answers, and then I'm going to go back up here, and I want to make sure I'm going to put this as meat per person also, so I have my units in there correctly. Now part B is going to ask for a percent change, which is pretty well. So we started with, we ended with 40, so ending number minus starting number over starting number. Look how lovely this is. 20 over 20 is equal to 1. 1 times 100 equals 100%. 5% increase. So the problem ended up being pretty easy to do as long as you could figure out how to do that. And with practice, more and more, you will learn how to better figure these out.